Ladies and gentlemen, and I would like to welcome you all for an insightful session on electric vehicle charging infrastructures. I'm Mitara Pereira, your host for the day, and I warmly welcome you to the fifth workshop of the Battery Technology and Charging Infrastructure for Electric Vehicles workshop series organized by IEEE Y2N Pro. To give a brief overview of this workshop series, this is a comprehensive course that offers both theoretical and practical insights into battery technologies and charging infrastructures of EVs. This series addresses the surging demand for expertise in the EV sector, focusing on battery systems and charging infrastructure. You will be able to explore the evolution, operational principles, and future advancements of EVs, delving into battery technologies and innovations aimed at enhancing efficiency and safety. Today's workshop focuses on electric vehicle charging infrastructures, from the scenario to the impacts and integration with electrical power systems and ICTs. Before moving on, we have some important announcements to make. We have already shared these guidelines to be followed during the workshop series. However, I will read the guidelines and make sure that you follow them for a smooth session. A quiz would be administered at the end of the workshop series on the 5th of October, where you would be assessed on the knowledge gained. The IEEE Credential Certificate will be awarded only if you achieve at least 80% on the above-mentioned quiz and attend at least 80% of the sessions. Attendance will be marked at 3 given instances of the session. Therefore, please be present throughout the session. The recording of the webinar will be uploaded to the Google Classroom. Please rename yourself using the registration number provided in the handbook and your name if you haven't done so already. Today, we are honored to have a distinguished academic with us who will guide you through electric vehicle charging infrastructures. Thank you, sir, for accepting our invitation and joining us today to deliver the keynote speech. Professor Giambattista Gruosso is an associate professor at Politecnico di Milano and vice chair of the IEEE Italy Section. He received his PhD in electrical engineering from Politecnico di Milano in 2003. His expertise spans electrical and electronic systems, focusing on smart mobility, smart factories, and smart grids. Professor Gruosso's research encompasses modeling and design of innovative electromechanical systems, power electronics, and material simulation. He actively engages in Industry 4.0 advancements and specializes in developing strategies for hybrid and electric vehicle management. As a senior member of IEEE and DL of VTS, he contributes significantly to the field through teaching, research, and consulting. So, ladies and gentlemen, please welcome Professor Giambattista Gruosso to deliver the keynote speech on electric vehicle charging infrastructures, from the scenario to the impacts and integration with electrical power systems and ICTs. The spotlight is yours, sir.
Thank you. Thank you to be here today. If you give me a few minutes, I will share the screen with my presentation. Okay. I think that you see the presentation. Okay. I am very glad and I am very honored to accept the invitation to have this distinguished lecture in this course. I think and I hope that it will be interesting, and I want to try with you to draw some aspects that are related to the topic of the electrical charging infrastructure. Today, in fact, if we want to talk about the diffusion, the spread of the electrical vehicle, we have to face with some challenge. And one of the challenge that mainly we have is the availability of charging points or in general charging system in order to make possible the use of the electrical vehicle in every kind of country, every kind of condition, and so on. One of the advantages that we have with the traditional fuel is that we can transport it, we can deliver the gasoline in every part of the world, in rural countries, in the cities, along the highway, and so on. Then it makes easy to refuel our vehicles everywhere. On the other side, the electrical vehicle needs to be charged very often, to be charged, and they need infrastructure, they need time to be charged, and so on. Then it changed completely the way in which we imagine the mobility, and so on. Few words. I want to add some words on what I'm doing. Respect on the presentation that well described mainly my profile, but I want to introduce in a deeper way what we are doing now. With my research group, we are working into the field of the electrical vehicle, trying to do an interdisciplinary work that include the electrical aspects, because we have to face with all the electrical rule, all the electrical constraints that are related to the charging system, but we need also to have some aspects that are related to the I think sustainability from the point of view of economical, environmental, and so on. And it is important to introduce into the study also these aspects. And at the end, we need to support these charging infrastructure by means of ICTs, or in general by means of digital backbones that enable some kind of services that can be delivered today. What I want to say during my presentation this day, at the end of my presentation, I want to arrive on the fact that these three components, the sustainability, the electrical aspect, and the ICT, will be integrated in order to create new business models that can enable in a correct way the diffusion and the spread of the electrical vehicle. As usual, or in general, as I typically do, I will ask you in some point of my presentation if you have questions, or if you have points that you want to discuss, and then we try to do an interactive section, and starting from this I can introduce complementary aspects and other aspects that are not discussed in the presentation. Every time that I do this kind of lesson, it is not easy for me to cover all the aspects, because I need to give a presentation that stay at a level of entry-level person, but at the same time I need also to give some concept that could be in advanced way. Then this presentation is an average between I think very easy, well, probably known concept, but also with new insight and new aspects that we can try to do. I want to start with this image, because I think that is important to try to do an analysis on what happens, or on what happens into the world in the last years. Here, the title of the slide, it is associated to 2020, but in general, we are discussing on the year that are just after the 2020, because the 2020 was a very strange year due to the pandemic constriction, but at the same time, the pandemic changed some, and not only the pandemic changed some things into the world, and then also the scenario it is changing. What we are seeing is that if we consider today the EV market, we see that Europe and China are at the same level. In the last 4 years, the whole Europe that have 47 million of person, that is a number very very low if we consider it with the 1 billion person, more than 1 billion person that is in China. We see that Europe increased the use of the electrical vehicle. If we consider that also I talk about Europe because I am based in Europe, then I see mainly what happens into the Europe, but these considerations are useful to try to understand what happens. We see that there is also a very big number of electrical vehicles sold into the 2020, also in China and in the USA. In the rest of the world, the number of vehicles are more or less 43,000. Then it is a very low number. But if we try to consider it respect to the density of the electrical vehicle, respect to the square meter associated of the extension of the country, what we see is that mainly the diffusion of electrical vehicle is associated to the town, is associated to the city, is not so associated with the countryside of a nation, because there are some important constraints due to the diffusion of charging stations and so on. Then the diffusion of the electrical vehicle, we see that it is very low or not existent in a lot of countries, because it is not easy for geographical conditions, for climate conditions, and so on, to have the same availability of the electrical chargers. And then it is well known at this point, not only into the research, but also into the market, it is well known that it is important to do a leverage on the diffusion of electrical vehicle, but we need also to increase the diffusion of the charging station in order to allow to the person to use the electrical vehicle not only into the way. But we have also to consider another aspect. Probably the mobility will change completely respect to the way in which we are usual to see. Today, in the most of the country, especially into the developed country, we have 1 or 2 vehicles for each person. We use the vehicle for short term, short trip, but also we use the vehicle for long trip. We decided to do in vacation, and we do 1,000 kilometers with our car. We use the car into the city. We use the same car for the both tasks. More or less, there is a statistic that say that every of us into the world, if we don't use the car for work, and we use also the car for family needs, more or less every of us use the car around 20,000, 25,000 kilometers per year. Then if we consider this, and if we try to divide how we use, probably in the most of the case, we use few days in a year to do very long trip, for example, to go into the vacation, holiday, and so on, and then we do more or less 5,000 or 6,000 kilometers for vacation. The remaining part of the use of the vehicle is made for the use house to job or house to daily life in general. I think that if we consider this, probably we need to imagine that every family that lives typically inside city or similar could have a small car for electrical town mobility and needs to use other mobility the device for long-term trip. Could be plane, could be train, could be rent car or similar. Then it is important to imagine that we can't keep the same electrical vehicle scenario that we are usual to see when we talk about gasoline vehicles and so on. Then it is very important to imagine that the diffusion of electrical vehicle is associated to the diffusion of charging point, but also it is associated to a very big change of mind in this sense. If you imagine that when you have to do a travel, you need, if you have a traditional electrical car, not a new generation car, but you have a traditional electrical car, you need more or less 3 or 4 hours for a good charging. Then it means that when you plan to do a travel, you need to move for 300 kilometers, and then you have to forecast that you have to stay at least 4 hours stopped for charging reason. Then you have to change completely the way in which you are traveling. And at the same time, it changed completely also the payload that you can put into your car, because part of the payload is associated to the battery or everything. Then, starting from this consideration, we can try to understand some aspects and so on. Before, when I were talking, I have seen an hand that was raised. I don't know if there is a question. Probably it was an error. Okay. If there are no questions, I think that it's better that we stop for a Q&A section after, and then also I will read what happens into the chat. Okay, I want to try also to understand here into the presentation. You see some reference. If you will receive these slides, and then if you look for the digital object identifier and you want to look to this paper, you can enter into a deeper analysis on what I'm saying. I decided to use for the presentation some material that you can read, that you can read. At the same time, I looked for similarity to part of the world that is very close or in the same area in which you are located. Then I start on this work that to discuss what happens in India, but you can find a lot of works in the most of the country and so on. What we see is that if we look what happens in the last years, we see that by sure China and Europe will continue to increase the number of the electrical vehicle that will be sent. In Europe, we have a new deal that say that by 2030, we will stop the production of fuel, gasoline, or other kind of fossil fuels by 2030, and then we have only to sell electrical vehicles. Also will happen more or less in China, where is a very big pushing into the direction to use electrical vehicle to reduce pollution and so on. But as you see, also other countries like USA will increase also the remaining of the world, the air WU is the remaining of the world. And we see that also countries in Asia that for now are not into the electrical vehicle market. If you see that what happens to India till 2025, the forecast is to have a very few number of electrical vehicles, and we see that in the remaining part, the number of electrical vehicles will increase. Electrical vehicle is by sure at the same time fashion way to have a mobility object. Then probably there is a lot of hyper attention on this topic, but by sure it will be a good opportunity. It represents a good opportunity to face with the global change. Probably we don't have a scenario. We'll have a scenario in which the 100% of the vehicle owner will use electrical vehicles, for the reason that I said before, that it is not possible to imagine for kind of trips and so on what we need to do. But it is important to understand that it is a good way to reduce, at least locally, the emission of pollutant and so on. Consider one aspect that typically, and I don't introduce, or better, I introduce very, very fastly now, but I don't analyze in a deeper way. If we consider now what happens into the mobility scenario, the personal mobility, the mobility of the families and the single user, it is not the most impactful mobility into the world. What is the impactful, the biggest impact of the mobility? It is the work mobility, the delivery of the goods, the transportation of the goods on the road, the use of fleet for delivery goods inside the city and so on. It is very interesting to do something that I read into the recent days in Norway, where they started more than 15 years ago to do a very cultural transition to electrical vehicle. What the statistical notice that now more or less 100% of the family got an electrical vehicle, or more than one electrical vehicle for personal mobility. But what happens is that the amount of gasoline that was sell in the last years, it is exactly the same. What means this? This means that the not personal use of the electrical vehicle represent by sure the baseline of the pollution into the transportation system. It is important also to work in this direction. The most of the policy that now we are doing into the countries are related to the personal mobility, not related to the good mobility, because in some cases it is easy. For example, for the delivery inside the city, it is possible to use electrical van or similar for the mobility, but at the same time, if you want to deliver very heavy duty objects, it is not easy to shift and to use electrical vehicle if you have to transport tons of goods from one part for 500 kilometers, 600 kilometers. Is not possible to imagine that the truck will be full electrical and so on. What I want to see, I want to start with some figures also to introduce and to do some scenario analysis before entering is this. Roland Berger, that is a consultancy company, very important consultancy company into the world. They introduce an index for several kind of sectors. They use this index to manage the maturity level of one country respect to one topic. They use this kind of methodology also for the electrical vehicle. And what we can see that in the last 5 edition, if into the first edition, we were if into the first edition, the China leads with this index at 17, the state of the electrical vehicle, there are a lot of components that concur to this index, followed by Netherlands, Norway, France, and so on, Italy. What we see that in the third edition, the number of countries increased a lot. There were a lot of new small and big countries that enter into the electrical vehicle market or in general usage. We see that the China increase a lot, but also other countries like Germany and so on, they will arrive to the same level of China the year before. And if we see what happens in 2024, we see that the China remain more or less stopped or in general still at this level. The other country increase, and if I said before, if we consider the whole European market complexively, it goes. It becomes bigger than the China market and so on, but also very small or very interesting countries like Malaysia, Vietnam, Indonesia, and so on, they start to increase. It is sustainable, this. More or less, it could be sustainable if we see what happens from the point of view of the pollution and other point. But if we see what happens from the point of view of the diffusion on the impact of the electrical grid, what we can see in the remaining part of the presentation is that it is not easy to manage and to cope with this very big increasing of the electrical energy request for charging behaviors and so on. I want to start out. I want to enter in a technical detail, or more or less into the introduction, because when we talk about electrical vehicle, as I say, it is not easy to do a classification. First of all, if you think about electrical vehicle, in the most of the case, you think about cars. But into the electrical vehicle, we have to put also the trucks, we have to put also the trains, we have to put the boats, we have to put also the motorbikes, the scooters, and so on. Then there is a very big amount of mobility device that use electricity as propulsion system. Then we have to cope with a very complex and different scenario, and then it is not easy to have a solution that is useful for all the scenario. Now, we focus in this presentation on the cars. More or less, we focus on the cars, or in general, on the vehicles that can be considered close to the car. in general, personal mobility. When we talk about electrical vehicle, we have to imagine at least four category of vehicle. Two of these category of vehicle are out of this the today presentation, or in general are out from our interest at this point. The first one are the hybrid electrical vehicle, because the hybrid electrical vehicle are autonomous system, because they are fueled, they are not charged using the plug, and then they are not into the scope of our presentation because we are talking about charging infrastructure. The other kind of electrical vehicle that are not inside our discussion are the fuel cell electrical vehicle, because the charging infrastructure of the fuel cell, it is completely different. But the fact that I deleted these two from my talk is not synonymous of the fact that they are not important, because probably hybrid electrical vehicle will be the at least next 10-year solution. Then it will be the soft transition from full gasoline vehicle to electrical vehicle, because this allows, for example, to have long trips and to use it for manage to reduce the pollution of the vehicle, because you can manage with the electrical part of the vehicle, you can manage what happens into the system. Also, the fuel cell are completely electrical vehicle, but they are fueled by the hydrogen, and they will be very promising, because also the production of electrical energy, it is done in a clean way. Because when you produce electrical energy, in other case, you can do it by renewable sourcing, then in a clean way, but also you can do it by using a nuclear plant, or you can use it gasoline plant, or other kind of plant that can be very pollutant in a global way. Then, by sure, the two elements that I put on the right and on the left will be very important in the next future, but they don't impact on the electrical infrastructure, on the electrical grid. Then we focus mainly into the two elements that are inside. Plug-in hybrid electrical vehicle are the electrical vehicle that can be plugged to be charged, but if you don't charge it, they could be used as gasoline vehicle. Then they are very promising. At least in Europe, they are now a good percentage of the electrical vehicle, because you can use it for more or less from 50 to 100 kilometers. The new models can arrive more or less, they have an autonomy of 100 kilometers. In average, you can suppose that you can do 60 kilometers. Then it means that you can use it into the town for the daily trip from house to job, and from house to the shopping center, or other needs that you have with your car, using completely electrical. But if you need to go outside the city, you need to do a long trip or in similar, you can use the fuel. If you don't need to stop for 3 hours to do a charging when you are traveling, because you can refuel using the gasoline or similar. They are not completely electrical vehicles. They are very similar to the hybrid, but with the advantage to have the opportunity to use it in a full electrical way. The battery electrical vehicle, the so-called BEV, are the completely electrical supplied vehicle. When we talk about the impact of this vehicle on the infrastructure, we have to consider that the way of use, the way in which the user use the two vehicles is completely different, and then we have to consider some aspect and so on. What about the charging technology? The charging technology are more or less subdivided in three categories. There are the conductive, that means that you have the plug. There are the inductive, so they are the so-called wireless power charging, and you have the battery swap. Typically, the battery swap is not for the cars, or in general, it is not used mainly for the car, but it is used for mobility like scooters, like electrical bicycles, and so on, where especially when you have sharing fleet or this company for the vehicle sharing, they change the battery, simply swapping without charging. Then you can have a battery site in which you take the battery charge and you can go and to around the city for doing this kind of battery swap. But typically what for our point of view, conductive and inductive are more or less the same impact on the grid. Today we have mostly conductive, and the use of inductive, it is a new perspective, and then it is increasing. When we talk about conductive, we have essentially three kind of in general two, but here you see three, but they are exactly two. One is the AC. The AC means that your vehicle is plugged directly to the power grid, and it is on your vehicle that there is the charger. Then on your vehicle there is a charging that convert the AC power to the DC power that you need for charging. They are different, then I will show you in another slide, different kind of level of charge, and you see that you start from 8 hours for the domestic application, and you arrive to 30 minutes if you have a very fast. If you see 3.6, 22, 43 kilowatt are constraints due to the national or in general standard rules that all the devices that use for the protection into the distribution system are associated to this level of power. Then you can't increase a lot without violating the rule, the grid code in general that is associated to distribution grid. If you consider what happens from the DC, in this case, you are into the middle, you have another device, then your vehicle is not connected directly to the grid, your vehicle is connected to the device, it is the device that is connected to the grid. Then you don't have in your electrical vehicle a charger, the charger is only outside your vehicle, then in this case you can do the fast and the ultra fast. You can arrive up to 38 minutes, 50, 20 minutes to have the charging system and so on. If you consider the inductive, for now, the amount of energy, it is lower, but you can arrive to a charging more or less in 20. If I see here 3.8 minutes for the charging, I say, wow, I can charge my car in a very, very short time. Then I can suppose it is the same time that I need for refuel my gasoline car. Okay, I find exactly the way. But if you consider you are delivering 350 kilowatt in 3 minutes, then you are taking in 3 minutes what typically takes a building of 15 floors in which there are 6 families per floor. Then it is as all the building, it is drawing contemporary this amount of energy. Then your car will impact on the grid for 3 minutes exactly as a very big plant, industrial plant and so on, can impact to the grid. Then faster is the charging system, bigger is the impact of the charger on the grid. And then suppose that you have a city with several of these cars that want to charge at the same time, you can face a with very important problems into the grid. When we talk about this is what I show you before is something associated to the more or less common speaking. Then we have a very subdivided distinction. But if we look to the what's said into the standards talk only about 3 kinds of charger. One is the level 1. Level 1 is used mainly into the family for residential, and for the 70% it is in private, is not in public. It is more or less night used during the night or for a long time, because it requires a lot of time for the charge. It means that you can plug it directly into your socket. You don't need any kind of device to do this. You can use it in your garage or in similar, and it takes more or less from 8 hours to 20 hours and to do a charger of an electrical vehicle. The level 2 is faster, more or less it takes 5-6 hours. This is the state of the art, also into the public non-residential application. It represents 94% of the installation today, or the usage today. And we have the DC fast charging that are into the range of 15 to 45 minutes. And it is more or less what happens or what will happen into the future. And it is supposed to 2023 to have 37. These numbers say that now this is the most used are the level 2, and you see that this is the future, or more or less it is the future. Here you see some level of voltage, because in the previous slide I show you what happens from the European or in general in the most of the case standard level of voltage. Here we have the level of voltage associated more or less to the USA voltage value, but it is the same classification and so on. I will spend few minutes to the charging scenario, and on this slide, at the end of this slide, if you have questions, we can answer to some questions. Charging scenario. It is not easy to do a classification of the charging scenario, because this is an example of the charging scenario. We see we subdivide from private and public access. Private means into hotels, into office, into some location in which not every person can access. And we have also the public access, means on the street, into the commercial area, and so on. Then we see that we can have individual parking and charging. Every person can do it, or collective parking and charging. It means company fleet, bus depot, but we see what happens into the public access. For example, we arrive also in this kind of hyper hubs of fuel station model. That means that you can go during your travel, you can go inside these hyper hubs that are not associated to all the location, which you can enter with your car, and you can fuel your car in very few minutes. The idea could be that starting from the bottom, use it into the town, you go to use the second level. You can use the second level where you have very big parking space that could be into the neighborhood, or it could be into the commercial center, so on, and you use this kind of hyper hubs into the highway or into the connection road between two cities and so on, and with dedicated infrastructure. At this point, I will stop here because if you have questions, you can do it, or I suppose by voice, raising the hand, or into the chat. Who is the first to do the questions? There are no questions? Are you here?
Yes, sir, we are here. Seems like there are no questions right now at the moment.
Okay, perfect. Then I will go ahead, and then if you have questions, I will honor to answer to your question. Okay. What we are seeing, there is different scenario, there are different point of view, there are different aspects that are associated to the use of the electrical vehicle, and there are in general a lot of aspects that we have to consider when we talk about the design, and that when we talk about the forecasting on the location, or in general to where to put the charging station, to make sure that the charging station will be useful for the use and so on. We see what happens. We see that if we want to analyze what happens into the world in the next years, what we see is this one. This level is the number of the dark gray is the number of the level 1 charger. The blue is the number, the percentage of the person, the usage of the level 2 chargers, and the light gray is the percentage of the use of the fast charger. What we see is that today, more or less, we have that the complexively most used level amount of energy, it is associated to the level 1 and to the level 2. it is increasing the use of the chargers and so on. If we want to increase, if we want to see what happens into the rest of the day, we see that it will be an exponential growth in every part of the world. It will be an exponential growth of the usage of the electrical vehicles, charging the infrastructure. And then we have to face with this aspect. For charging technology, if we see what happens for charging technology, we see that the level 1, I think that we can take Europe and China, the amount of the level 1 will be reduced significantly. The amount of level 1, level 2 will increase, but what we see is that will increase in a significant way the amount of energy into the DC way. And this because the mobility scenario that is associated to the electrical vehicle, it is to a medium term, medium trip vehicles that then we need to use it for a low range, high range or medium range travels. Then we need to charge in a fast way. Then we are increasing the number of this system. When we see what happens from the public and from the home-centered, we see that at this level, we are reducing the home charging point because it is not possible to use or install more plugs into the home, and we are moving into public charging station. If we look to European Union and China, we see that more or less the use of long distance, this, what I called it before, hyper hubs and so on, it is more or less constant. We see an increase into the USA because it is completely different, the approach. European Union and China have a very good transportation system between cities, high-speed trains or in general trains or other kind of connection that allow to the person to move city by city without using without using vehicles in general. In the United States, the idea is to use the car also for city-to-city movement, also to state-to-state travels and so on. Then the idea is there is a completely different way in which the mobility is seen in this country. If we talk about the public center scenario, if we walk about the scenario which it is home-centered, what we see is that into the European Union we are. It say more or less the same things that I said before. It is decreasing the use in home. Then the idea is to increase the public and so on. Why we need to be aware on the connection of the electrical vehicle to the grid? There are several reasons to do this. First problem is the step that we can say or that we can see into the grid, or in general, what happens? There are too many chargers that are switching on at the same or off at the same moment. Where for moment we consider an interval. Then suppose that if we look to the statistic, you see that the charging time into the house is more or less the same. At the end of the working day, more or less around 6 p.m., all the vehicles are connected to the grid. What happens? What happens that the power starts from a baseline and it increases in a step way. What happens? What means this? That from the point of view of the production of energy, you need to have a step of production. I suppose that the most of you are aware on the fact that the energy is a conservative phenomenon. Then you can't produce energy if you haven't request of energy. The total amount of energy produced has to be equal to an energy consumed. Then you can't have a buffer of energy. You can't have, from the point of view of production, a buffer, and then you have an amount of energy that is ready to be used when you have this step. When you have this step, what happens? You start to produce exactly into the point in which it is requested. This means, from the point of view of the generators, that you have to change the regulation curve and to follow the request. And it will be critical because you can have a situation, point of work of your grid, in which you are at the limit. Then your generator is already arrived at the nominal value, then you haven't other energy that you can give. Then what happens? It can impact on the stability of the grid. Then you can't follow, or you have to disconnect some loads in order to follow and to give the availability of energy. The other point is the ramp. Yes, at the same point, but the ramp means if we consider a larger interval, for example, if you have 3 hours, 4 hours, it is what happens during the day in a public center. If you have a public lot, a parking lot, you see that the car arrive in different moments. Probably they arrive from 8 in the morning till the 11 into the morning, then they start to charge. Then you have a ramp. Step and ramp are different behavior, but they are both critical from the point of view of the system, because there are some generators, some electrical centrals that needs to give discrete quantity of energy. For example, if you have I don't know, if you're supposed to have hydroelectric energy, probably you can regulate it, but you can change so much the flow of the river. Then when you arrive at a certain value of the flow of the river, you have fixed your system. Then it is not possible to change continuously the amount of power that you can give and so on. Then they are both important aspects. The other point are the oscillation. Oscillation means group of a certain number of charging stations that continues connected, disconnect. What means? I am in a parking station, I arrive, I connect my car, I charge my car, I go away. There is another person that is into the queue that automatically connect. Then you see that from the point of view of the socket, you see that your energy, it is going up, your energy requested, going up, going down, going up. Then in an interval, 1 day, 1/2 of day, you see that there is an oscillation on what happens into the grid. There are, and this is from the point of view of the plug, but there are other aspects that are associated to the behavior of the charger. because when you connect the grid, your car, every charger behaves in a different way. Then they use different algorithms, they use different strategy and so on to give power to the battery. Then you can see several aspects that can be happens not only into the insertion phase and into the disconnection phase, but they can also happen during the 3 hours, 4 hours in which the system is connected. Then it is very important to try to face to this aspect. This is an example on what happens into the system. Typically, when you see what happens during the day, there are a base load that are the basic that you fix, and more or less it is different the amount, but it is the shape, it is the similar in every part of the world. You see that there is a characteristic curve that you see that has a peak into the morning, and there is another peak during the afternoon. These two peaks are associated typically to the what happens into the behavior, because here you are in the working phase, and then more or less you are starting your devices, your working devices, and so on. And here you are moving to home, and then you are starting your devices. If this is the typical value, when you add electrical vehicle, you see, for example, that you add the red part to the car, then you have an increasing of the peak. And this increase of the peak could be, like in this example, exactly in the same point where is the peak, and then it is very easy to forecast, but in the most of case, it is not so easy to forecast because it follows different behaviors and different curves. Then it is very important to try to manage and to try to understand what happens in this point. I want to show you this, and after I will ask again if you have questions. If you see, this is a very interesting paper. I suggest you to read if you have time to read it to understand that this peak, it is not always in the same position. It depends on the scenario. If you have an high penetration into the home, you see that the peak is more or less here and here. If you have high work, the peak shift in this position, and so on. Then it is important to focus the fact that the position of the peak change depending on the scenario. It is not easy to give an answer where is the peak. Also because today we have some peaks, but we have not a consolidated peak, because the amount of the electrical vehicle that we have, it is not so big. So when we have to do some analysis, the analysis are not easy to be considered as general. We know that what happens is more or less this, but today we have in a city, I don't know, 1% of electrical vehicle. What happens when the vehicle will be 100%? Imagine every of you when you use the car. You don't know. Today you use the car in a way, tomorrow you use the car in another way, for 3 days using a car. Then use of car means discharge of the battery, then means needs to charge. Then if you imagine your behavior, you see that there are some of you that are commuter, then use the car every day. There are people of you that use the car only the weekend or in holiday. There are other of you that use the car only during the working day, but only in the afternoon to do some things. The others are in the working day, but they work into the morning. There are persons that work in shift, then some days they work in the morning, some days they work in the afternoon, and so on. Then it is not easy to try to do this. But why it is important to forecast? It is important to forecast because it impacts the design of the distribution and transmission grid. How many energy I need? I need to charge vehicle, I need to supply my offices, I need to supply my houses, I need to supply my commercial center and so on. Then how many central I need? What happens if I forecast to have solar energy because I supposed to have the peak? What happens when I haven't the peak? I have a lot of energy that is made by the solar, but the main quantity of energy it is due during the noon, and probably if I shift the peak from the noon to the afternoon, I see that it changed completely. Then it is very important, it is very strategical into the forecasting and so on. Since the next slide we enter into other aspects that are associated to the ICT and in the smart infrastructure, I think that could be useful to do now a discussion of the previous topic. I don't know if there is questions or there are some of you that want to ask something. I will wait 5 minutes for the questions, and as also we do a 5 minutes break for my voice mail. So if you have question, please write into the chat or raise your hand. Okay, I think that we can go over. Okay, there is a question. Can you explain last 3 graphs? You mean these 3 graphs? 1, these, and 3. Okay. This is what we try to explain after, but or in general, part of what I want to explain after. First of all, the first graph, the first diagram say if I do an uncontrolled charge, it means that I allow that every person can connect when he wants. Okay? What we can see is that if we change the amount of adoption of the electrical vehicle, 20, 40, 60, 80% of the vehicle into the city or into the area that we are considering, we see that there is, in the case of uncontrolled charging an increase of the peak in percentage that is associated here. What are the four different levels? One, it is the universal home, that means use completely at home. High home means that you use mostly into the home. The third means that you use very few at home, and the most of the time use into the work for charging, I mean. And the last is the low home, low work. It means that you use in part at home, in part at work. Then, if you consider these three are different, they are not mine, then I take it from the graph, that I agree with you that are not very easy to follow, but you see that if you consider a percentage that is increasing into the low home and low peak, that are the highest two, you see a very big increase. Why this? Because at home, if you consider the high home, that is this one, you have male, and also the universal home, you have mainly charges that are at low level of power. They are level 1. Then you don't have peaks because you need 8 hours for the charging. Then you spread your energy completely. Yes, there is an increase because without is not the same, but it is not so high when you use the public charger at work or outside, in general, outside home, where you use more or less level 2 that are up to 45 kilowatt. Then there is an increase. This is in the case of the uncontrolled. Here, if you try to say to the person, go to charge at 9 in the morning, go to charge at 12 in the morning, yes, excuse me, it's 9 in the afternoon, charge at 12 in the morning, and charging in a random way. You see that when you fix, it is obvious this, but when you fix a time for the charging, you see that there is a peak that increase significantly into the 4 category according. What happens if you say to the person, charge when there is the minimum of the peak? If you consider, I go back here. If you consider here, suggest to the people to charge here or to charge here. If you suggest to the charge here, what happens is that, yes, there is an increasing of also of the peak, but you see that the increasing of the peak change according to this. This introduces the fact that if you can control the charge, you can control the impact on the grid. It is trivial what I said, but the future, and it is also what I will try to explain after, the future of the charging station is moved from an uncontrolled way, where the people control when they want, to a controlled way in which the people charge when the system allows them to charge. This is a completely new way to see the charging behavior of the person. I don't know if I answered to the question. There are other questions? It is, I think they are used from USA point of view, then the data are associated to the USA. But your question, it is interesting because say this, there is not a way to use data globally, because every country, every city, every situation change completely the behavior of the charging system for several reasons. One reason is by sure the climate, because if I stay in a city in which I have a lot of rain, probably I don't like a lot to charge my vehicle when it's raining, to go out to connect the plug and then to go to I prefer to park close to the office and not in the charging station and so on. If I am in a sunny place, probably I change completely my habits and so on. Then there are some climate condition, some diffusion condition, some kind. For example, there are countries in which you use a lot of Tesla, then you have vehicle of certain category, certain amount of energy and so on. There are countries in which we have a lot of very small cars, small electrical cars, and so on. Then I think that it is not easy to have this in a general way. Then these graphs are by sure for the USA. I don't know if it's a city or it is completely on the USA. It is not easy in general to do this. Here, I think that is made not into the summer or in winter. It is made in an interval coherent. They analyze the data of several months, but are always the same months. But I don't know. I don't remember in general if they are summer or not. But typically they are working days. Then it means that they are during the working period. There are other questions. Otherwise, I will go ahead with the presentation. But I will come back to the question also after. Now I go away and so on. What I just said is that in the future, we will move into smart infrastructure. And first of all, we have to consider that the user is into the center. Yes, you have a problem from the point of view of the grid, you have problem from the point of view of the parking lots, you have problem from the point of view of the congestion of the city. Then you need, as a grid owner or city owner or in general other things, to do some things. But remember that the user is the user. If I want to charge, I charge. If I don't want to charge, I don't charge. If I need to charge, I charge. If I don't need, I don't charge. Then the user, it is the center of every process. I need to create a system that make possible to the user to the child. Then I have to follow the expectation about the price, about the quality, and so on. Then everything I do has to be done having in mind that I have to satisfy completely the expectation of the user, that is, in the most of the case, my customer. Then I need to follow this. If I have to guarantee privacy protection and so on, if I want to get information about the state of charge of the vehicle, then in other words, if I want to do a smart analysis, a smart behavior of my vehicle, I need to know the state of the vehicle. Then I have to enter into the user vehicle to understand when he needs to be charged and so on. Then it is very, very important to consider. Then if I design according to the expectation, if I solve the issue associated with the shared control of the battery, so I can create new services for vehicles and drivers. For example, I can send a notification into the app to say, okay, you are close to a charging station. Now, if you charge now, you can get 50% of discount. But why I say you this? Because I know the state of charge of your battery. I know that you need to charge probably in the next 20 minutes, and I prefer that you charge now instead of charging in the next 20 minutes, because I want to anticipate the peak, and I know that there is a parking lot that is free, and then I prefer that you go there and not in another parking station. Then I need to know exactly where you are, the state of charge of your battery, to propose you something that is interesting to do. This means that it increases the complexity, also because into the process to arrive to a smart charging infrastructure is that we have to interface different actors. We have the AV user, but the AV users are different. We have private, company fleet, taxi fleet, sharing fleet, trucks drivers, and so on. Then also the AV user, it is completely different. We have different manufacturers. Then we have a car that allows to give you the state of charge. We have another car in which it's not possible to have the state of charge. We have a car that gives you the state of charge in joule. There is a car that gives you the state of charge in kilowatt hours, and so on. Then you need to cope on these objects. But also the charging operation are different, because you typically the app that used for the charging, the mobility app, are only reselling of charging service. But when you go to the plug is not of the service provider, but is managed by the different utility. Then the charging operator are completely different. There are different role, different regulation, different aspect. You have the price, the decision maker, and so on. Then you need to satisfy a lot of different actors in order to design and to deliver smart infrastructure and smart aspect. In a simple operation to buy energy to charge my vehicle, into the background there is a complex system. The vehicle user have to talk with the electrical vehicle, setting some parameters and so on. The electrical vehicle have to talk with the charging infrastructure. The charging infrastructure have to talk with the distribution system operator. Then you have to talk with the TSO and so on. Then there is a very complex, and there is a lot of different short circuit between different elements into the system. This makes not easy to imagine a smart charging infrastructure. But it is very important to have it. If we consider the EV and also the electrical, this study is a mix of the EV and also the thermal using into the house, but we see that will be a very big growth, and the use of smart charging will satisfy also introducing more or less 400 millions of pounds, English pounds, of savings. If I can manage in a smart way, or profits, it depends on the point of view in which you see this number, but when you talk about this, it is important to have a smart infrastructure, because you can save a lot of energy. And you need to design a digital backbone that have to be global. I have to charge my vehicles in every part of the country, or in general every part of the world if I want. using the same standards and so on. Then it is important to work in this direction. There are, as I said, several. This is a very interesting graph. I suggest you to look into this website. That is very interesting to read, to understand what happens. The smart charging controller can give information to the grid, can give information to the vehicle, to the user, can give information to the battery charging station in order to optimize the peak. There are different strategies. In my group, we are working on analyzing this kind of strategies, but there are several strategies. You want to maximize the revenue for the operators. You want to maximize the flexibility in order to reduce the peak, especially if you have renewable energy. You want to shift the behavior of the charging station in order to use the electrical vehicle as a storage system, then you can use it for managing and to share energy, to store energy in general. Then there are different strategies that stay into the smart charging controller, and the signal that he receives and share with the world comes from different actors. Then it is important to develop this kind of analysis. The smart charging system can dynamically adjust the charging rate of the EV. You can do the protection overload because you can avoid, for example, the contemporary starting of group of the electrical charger. Then you can reduce the step. You can reduce the ramp. You can work on the ramp. You can reduce the disconnection. Then you can decide to coordinate the charge between different vehicles that stay into the same station and so on. No, you can also do some charging strategy that prioritize the needs of mobility. Then if me, you, and another connect the vehicle at the same point, but I have to go away before you because I set into the settings of my vehicle that I have to go away in 1 hour, and another one set that have to go away in 3 hours because he needs to pass to other duties. Then you can define the priority, and then you can give the biggest amount of energy to the vehicle that have to go away before respect to the vehicle that have to go away in another point. The smart charging system can also adjust the charging power in order to reduce the price, follow the availability of renewables, reduce the grid congestions, and then to do what is called demand response, and then can be an important actor of the new generation demand response. Into the backbone of this, there is exactly what I described before, but the benefit for the operators and the benefit for the electrical vehicle owner could be important and could be very interesting. What happens? I can do one of the sample could be the peak shaving. For example, it is the reduction of the peak because I can decide to redistribute this amount of energy in a spread way. In this way, yes, the electrical vehicle obtain the same amount of energy, but it is obtained in a distributed way. Then I can reduce this. I can do the spot market optimization because I can reduce, for example, this peak, and then I can put this peak and I can shift this peak in another point when typically there is a minimum. Then I can manage this. What I need to do this, I need to know the vehicle, but I need also to do to know the grid. Then I need to change this kind of information. This is, for example, there are exist into the market commercial vehicles and so on. Then this is the Bosch solution. It is the smart charger of Bosch, but there are also other kind of smart charger that can be used to do exactly this kind of operation. My presentation is ended. I want to show you other slide, but I want to show you after the discussion. Now the discussion it is open. I will start to answer to a question that I see into the chat. It is written by Kyler. What and where is the current technology on enabling EV owners to loan their battery to the grid for DER use? For example, during the workday, the EV owner can allow public use to use their battery during peak load. Okay. Today, if I consider the technology it is very, I think, front runner. It is possible to suppose that I can do it. There is not technologically constraint. There is only two constraints that now don't allow to do this. The first constraint are the fact that the car makers don't give the control of their battery. Today, there are not cars into the market that allow the bidirectional, exchange of information. Then the use of the battery as it. But we are doing in my laboratory, but also in other laboratory, some tests. For example, to use the car not for giving back energy to the grid, because this is not possible, because as I said, the car don't allow to do this. The technology that is inside the car allow. It is only a constraint because the car maker don't want to give this, and I will explain you why in a few minutes. But you can use the car for decide when you go. For example, the test that we are doing, we create an app in which the user, we have a small group of users that use a charging station into the university. They can say us the duration of the stay, 3 hours, 4 hours, and 6 hours. We will do an optimization procedure, and then we decide when start the charge. If we need to suspend the charge for every reason, we suspend the charge for every reason. If we need to recharge, to continue the charge, we go away, and then we introduce flexibility. Then today, the state of the art is the managing the possibility, at least at a research point of view, to manage the research, the flexibility. If I know how many times the user will park the car, I can manage the amount of energy that I can give him. The second constraint is related to the standard, the grid codes of the utilities and so on. Then there is not a regulation that allow to give back energy into the grid from the electrical vehicle, because you need to install some devices that allow the safety also of the grid. Today, when you have a storage system that can put energy into the grid, you have to introduce some safety devices and so on. That here the problem is where I install my safety device. They are installed into the charging system, or they are installed into the electrical vehicle. If I have an electrical vehicle, if they are into the electrical vehicle, when they connect to the charging station, I am sure that the vehicle have this safety device or not. And then there are a lot of there are discussion from the standardization point of view. Then technologically, there is not any point to do this. From the point of view of the two key points that I said before, there are some constraints. Why the car makers don't want to put any kind of this device or the control of the battery? Because they have a problem associated to they have to guarantee the car. If they know that the battery pack lasts, I don't know, more or less 5 years, because if you charge in a certain way for a certain number of things, then you can say, okay, I can give you the 5 years of insurance that if your battery goes wrong in this 5 years, I can change you everything. But if you do the vehicle to grid, what happens? I don't know how I discharge. I don't know how the battery is made. So I'm not so sure that the battery life will be 5 years. And why I have to guarantee 5 years of insurance on the battery when I don't know how the battery works and so on? Then they don't want to. Also for the safety devices and so on. What happens if my car goes to the UK market or goes to the USA market or go to the Indian market and so on? What happens? They are different markets. So I have to install in my car different components for different markets and so on. Then they prefer for now to stay into the side and to look what happens. I suppose that I answered to the questions. If there are other, please. Okay, safety device, what means? Typically, what happens if there is an outage of power into the grid? I have to be sure that there are no other point of generation. If I need to intervene into the grid for maintenance, I need to be sure that there are not injection of voltages, because my technicians have to be sure that when they close the main of the grid it is off of voltage and so on. Then when you use storage system, when you use PV system or other kind of distributed generation and so on, by rule, by technical rule, you have to put into the at the meter at the point of insertion a device that check if there is an outage, and if there is an outage, disconnect and interrupt, for example, the generation of PV, the generation of storage system, and so on. When you have a vehicle to grid, who is responsible to disconnect from the grid, to stop the generation of energy? It is the charger or it is the vehicle? So this is, for example, one example safety device. It's a device that decide, for example, when disconnect, when reduce the injection of the grid, when the grid is not satisfying some constraints from term of frequency, in terms of outage or other points. Other questions? if you have question, you can write. Meanwhile, I want to give you these other aspect. You will find it also into the slide that they will be checked. We are organizing a call for ideas with VTS, the Vehicular Technology Society, for innovation in vehicular propulsion technology to address climate change. It is mainly related to the young professionals, VTS, but in general, we can try to extend to all the young professional. And the idea is to have a call of idea. I will send you I send you, or in general, I will publish the instruction as soon as, and the idea is to collect some ideas. The best ideas will be evaluated by a group of experts, and they will be presented in a workshop that will be held in December in Milan. It will be in presence or in general. We try to have also online session. This is the price and so on. If you follow me on LinkedIn or Instagram, you will receive news as the call will be published, I think, in the next week. Here there are all my contacts, both LinkedIn and Instagram or other kind that you want. If you want to be in touch with me, you can feel free to connect to me. The presentation from my point of view is ended, so I am here for questions. I'm here for every comments and for every points.
Thank you, Professor Giambattista Gruosso, for that very informative session. Your insights have truly added depth to our participants' understanding, sir. Thank you for being with us today.
Thank you. It was a pleasure to be here, and I will be very in the future. I hope that if you organize other initiative and other events, I will be honored to be invited if you need.
Thank you, sir. We would like to take a moment to express our gratitude to our esteemed speaker, Professor Giambattista Gruosso, for accepting our invitation and sharing his valuable knowledge and expertise with us. Please accept our token of appreciation. Your presence here has set a high standard for the caliber of learning we can expect from this workshop series. Thank you once again, sir.
Thank you. Thank you again for the invitation.
Before proceeding, let's take a group photo to remember this valuable time we spent together. I kindly request the audience and the OC members to switch on your cameras to take a group photo.
I couldn't open my video. Excuse me.
Yeah, hold on, we'll work on it. I think we are good to go now. I'll give you a count and can cue. I'll smile and pose for the picture. 1, 2, 3, say cheers.
Cheers.
Okay, let's make sure we have got a good shot. Are we good to go, Anusha?
Yes, we are. Thank you.
Okay, thank you everyone. Also, please note that the quiz will be conducted on the 5th of October at the end of the workshop series. We have now shared a feedback form in the Zoom chat. Also, you can scan the QR code on the screen to access the feedback form. We kindly request you to take a few minutes and fill it out. Your feedback is extremely important to us, as it helps us to continuously improve and provide you with better experiences in the future. This will also be considered for your attendance. Moving on, the next session will be held tomorrow at 5 p.m., not 6 p.m. as usual. It will be at 5 p.m. tomorrow, where Professor Niles Pereira from the Department of Transport Management and Logistic Engineering of University of Moratuwa will join us to take you through the EV battery supply chain, the challenges of ensuring sustainability. As we near the end of the session, we sincerely hope that you found the workshop informative and thought-provoking, and that you leave with new insights and ideas. And with that, we conclude today's workshop. Thank you once again, and have a good night.